Okay, in Chapter 8, we're introducing hypothesis testing. Let me just read the definition in a desultory way. I don't think I'll press you on the definition, but it's a statistical method that uses sample data to evaluate a hypothesis about a population. We'll have a sample mean, capital M. The hypothesized population mean will be mu. And from there, we're going to make an inference, understanding that the inference could be incorrect. So, by the way, this is also known as one sample hypothesis testing, and also one sample hypothesis testing using Z. In the next chapter, we'll use T. It's a subtle difference, but we'll get to that in Chapter 9. If you'll indulge me, there are several times during this presentation where I'm just going to read, and I want you to bear with me. Because I really want to hit these high points. This is really analogous or very similar to what I would have done in class. But just for this limited time, for the first few slides, I want to really painstakingly walk through this. In very simple terms, the logic underlying the hypothesis testing procedure is as follows. First, we state a hypothesis about a population. Usually, the hypothesis concerns the value of a population parameter, like mu. For example, we might hypothesize that American adults gain an average of 7 pounds between Thanksgiving and New Year's Day. Before we select a sample, we use the hypothesis to predict the characteristics that the sample should have. For example, if we predict that the average weight gain for the population is 7 pounds, then we would expect or predict that our sample should have a mean around 7 pounds of weight gain. Remember, the sample should be similar to the population, but you do expect some amount of error. Next, we obtain a random sample from the population, and we count on it being random. For example, we might select a sample of 200 adults and measure the average weight change for that sample between Thanksgiving and New Year's Day. And finally, we compare the obtained sample data with the prediction that was made from the hypothesis. If the sample mean is consistent with the prediction, we conclude that the hypothesis is reasonable. But if there's a big discrepancy, we decide that the hypothesis is wrong. And we'll get into this in more detail here in a minute. Now, abstractly, this is vexing. This feels like a Russian novel. I don't appreciate all these words. We're going to get into a process, and the process becomes reflexive. The process becomes instantaneous. The process has the, I guess you could say, property of removing a lot of thought. But upon doing the process over and over again, the idea behind the process becomes more clear. I hope that makes sense. It's like playing tennis. If you hold the racket a certain way, it makes that very, very, very satisfying thwack sound. You hit it right in the middle of the racket, and it makes that really, really good sound. So it goes with this. We're going to do something that's going to produce a result, a process. And when the process goes well and you really understand it, these principles here tend to fall in place. So I want to introduce the abstraction first, but then we'll get to actual, a good number of problems here that'll reinforce that, at least 5 problems. So what we're envisioning is something about a population after a treatment. In this Thanksgiving New Year's business, it was after they went through the holidays. So the basic research situation for hypothesis testing, of course, these are right out of your chapter. It's assumed that the parameter mu is known for the population before the treatment. The purpose of the study is to determine whether the treatment had an effect on the population mean. When we go into this further, the assumption that we're going to make is that it didn't make any difference. We're going to assume that the treatment that we underwent did not have any influence at all on the population mean. And we're going to test the probability of obtaining means given that assumption that it didn't make any difference. Let me just preview that right there. So here's another way of showing this. From the point of view of the hypothesis test, the entire population receives the treatment, and then a sample is selected from that treated population. In the actual research study, however, a sample is selected from the original population, and the treatment is administered just to the sample. From either perspective, the result is a treated sample that represents a treated population. And again, we're going to assume as a default that whatever this treatment was, whether it was lowering temperature in a drug or what have you, that it didn't make any difference. And we'll look at distributions of sample means with that assumption that it didn't make any difference. And by the way, by way of preview, we're going to assume that this not making any difference, if you will, is broadly known as something called the quote-unquote null hypothesis. And I know you've heard of that, and we'll get to that in some detail here shortly.